Did you know? Some of the world's largest cargo ships are powered by engines so enormous that they can be as tall as a 4-story building and weigh more than 2,000 tons. These incredible machines move vessels carrying hundreds of thousands of tons of cargo across oceans for weeks at a time. But here's the question that surprises almost everyone. Why aren't these giant engines simply switched off whenever the ship isn't moving? After all, your car engine can be stopped and restarted in seconds. So why is it different for a cargo ship? The answer is far more fascinating than most people imagine. It isn't just about size, it's about engineering, physics, fuel technology, safety, and the economics of global trade. A single decision to stop the main engine at the wrong time can delay deliveries worth millions of dollars, disrupt international shipping schedules, and even put the ship at risk in rough seas. Today, we're going deep inside one of the most powerful machines ever built by humans to uncover the truth behind these engineering giants. Every day, more than 50,000 merchant ships travel across the world's oceans, transporting nearly 90% of global trade. Everything from smartphones and laptops to cars, medicine, food, clothing, and construction materials reaches different countries by sea. Without cargo ships, modern life would look completely different. Supermarket shelves would empty quickly, factories would run out of raw materials, and international trade would slow dramatically. At the heart of every one of these massive ships is a marine diesel engine unlike anything found in a car, truck, or even a train. Some of these engines produce more than 80,000 horsepower, while running continuously for days or even weeks. Instead of spinning at thousands of revolutions per minute like a car engine, many large marine engines operate at only around 60 to 100 revolutions per minute. Despite this slow speed, they generate enormous torque, giving them the power needed to move an entire floating city across the ocean. One common myth is that cargo ship engines are never turned off. That isn't completely true. During long stays in port, major maintenance, or dry dock operations, the main engine is normally shut down. However, while a ship is sailing across the ocean, the engine is usually kept available for operation, because stopping and restarting it is a far more complex process than simply turning a key in a car. That difference is what makes these engines so unique. The first reason lies in the type of fuel they use. Unlike the clean diesel used in most road vehicles, many large cargo ships traditionally burn heavy fuel oil, also known as bunker fuel. This fuel is extremely thick, almost like cold tar or asphalt. At room temperature, it barely flows through pipes. Before it can even reach the engine, it must be heated to a very high temperature, so it becomes thin enough to pump and inject into the cylinders. Imagine trying to drink honey through a straw after leaving it in a refrigerator. It would barely move. Now imagine that honey becoming even thicker than that. That's similar to what heavy fuel oil is like when it cools down. If the heating system isn't managed properly, the fuel becomes difficult to handle, making engine operation much more complicated. This is one of the many reasons why marine engineers carefully monitor fuel temperature throughout a voyage. But fuel alone isn't the whole story. The engine itself is an engineering masterpiece. The pistons inside the largest marine engines can be taller than an average adult. Each piston travels up and down inside massive cylinders, converting the energy from burning fuel into mechanical power. The crankshaft is so enormous that it can weigh hundreds of tons by itself. Every movement must remain perfectly synchronized because even a small problem inside such a giant machine could lead to extremely expensive repairs. Another major difference is the way these engines are started. Your car uses a small electric starter motor powered by a battery. That method would never work on an engine weighing thousands of tons. Instead, large marine engines are started using compressed air stored in high-pressure air bottles. Powerful bursts of compressed air push the pistons until the engine reaches enough speed for fuel combustion to take over. Because the compressed air system is limited, engineers cannot endlessly attempt restarts. Every failed start consumes valuable compressed air, which must then be replenished using air compression. This is another reason why unnecessary engine shutdowns are avoided during critical stages of a voyage. And this is only the beginning. In the next part, we'll explore why thermal stress, safety at sea, fuel systems, maintenance procedures, and the economics of international shipping all play a crucial role in determining when a cargo ship's main engine should or should not be shut down. As the cargo ship continues its journey across the open ocean, the giant main engine works continuously, producing the enormous power needed to move thousands of containers across vast seas. Deep inside the engine room, marine engineers monitor oil pressure, cooling systems, fuel flow, temperatures, and vibration levels every hour. Even the smallest change can indicate a problem, so constant inspection is essential to keep the ship operating safely. One of the biggest reasons these engines are rarely stopped during a voyage is safety. The weather at sea can change without warning. Calm waters can quickly become dangerous storms with massive waves and powerful winds. In these situations, the captain depends on the main engine to maintain control of the ship. Without Without propulsion, the vessel could drift with the waves, creating a serious risk for both the crew and the cargo. Efficiency is another important factor. These giant marine engines are designed to operate continuously at a steady speed. Running for long periods reduces unnecessary stress on internal components and improves fuel efficiency. Engineers carefully maintain the lubrication and cooling systems to ensure the engine performs reliably throughout the voyage. After traveling thousands of miles, the ship finally approaches its destination. The bridge and engine room begin preparing for arrival by gradually reducing engine speed. Once the vessel is safely secured alongside the dock, the main engine is shut down. However, the ship does not lose power. Auxiliary generators continue supplying electricity for lighting, communication systems, cargo cranes, pumps, refrigeration, and every essential onboard service. While the ship remains in port, engineers carry out detailed inspections and maintenance. They check pistons, bearings, fuel injectors, cooling systems, and lubrication equipment. Worn parts are replaced, oil samples are analyzed, and every maintenance task is recorded. This preventive maintenance keeps the engine reliable for future voyages. When it is time to leave port, restarting the engine is a carefully planned process. Engineers first verify lubrication pressure, cooling water circulation, fuel temperature, and compressed air system. High-pressure compressed air slowly turns the enormous crankshaft until fuel combustion begins. Once the engine reaches a stable operating speed, the ship is ready to sail once again. Modern cargo ships are becoming cleaner and more efficient with advanced electronic controls and alternative fuels such as liquefied natural gas and methanol. Yet one fact remains unchanged. The main engine is the heart of every cargo ship, quietly powering global trade every single day. Without these extraordinary machines, factories would run out of raw materials, supermarkets would struggle to keep products on their shelves, and international commerce would slow dramatically. Hidden beneath the steel deck of every cargo ship is one of humanity's greatest engineering achievements. Working tirelessly to connect continents and deliver the goods that billions of people depend on every day. The next time you see a giant cargo ship crossing the horizon, remember that deep inside its hull, an incredible engine is working around the clock to keep the world moving. If you enjoyed this documentary, don't forget to like the video, subscribe to the channel, and turn on notifications for more fascinating stories about the engineering marvels that power our modern world. Thank you for watching, and we'll see you in the next documentary.